So the answer is?
1458.83.
Okay, first of all, this is money, so we need to make sure we put a dollar sign on our answer. Secondly, the decimal value that was displayed was much longer than this, but we want to round to the nearest hundredth, to the second decimal place, because this is money and that's how we do it. So for a 15-year loan at 4.55%, excuse me, Deb and Larry would pay $1,458.83 per month, every month, for the next 180 months. So if they're, can you still see this?
Yep.
If they're paying $1,458.83, 180 times, plus the $50,000 they put down, this will give us our total amount paid, which is payment times N plus down payment. And so if you second quit out of the TI, or if you menu 1 on your Casio, that will bring you to a regular calculator screen where you can type in the payment of $1,458.83 times 180 payments plus the down payment of $50,000, and your grand total should be
$312,589.40.
Okay, and I'm assuming you rounded that appropriately. Wow, $312,000 for a $240,000 house? What's going on there? The house is $240,000. Why are they paying so much? Because there's the interest charge, exactly. So to find the total interest paid, you take, this is how the book shows it, so this is how I'm showing it in this video. You would take the payment times N, total payments, minus the PV, the amount that you borrowed from the bank, the amount of the loan. So that would be $1,458.83 times 180, just like in the previous problem. And then you subtract the amount financed of $190,000, and is it $72,589.40? Does that sound right?
$72,589.4.
It is indeed $72,589.40, but you need the dollar sign and, of course, rounded to the appropriate cent. So here is your total amount paid, and here is your total interest paid. There is a part D, but I'm going to do that as a separate video. I really want to treat this question similar to the mortgage project, even though the down payment is a little bit different. So now the next thing I'd like to do is calculate this 4.407% for 30 years and see what the difference in the 15 and 30-year loan terms would result in. So again, I will go back into my TVM solver. And since we have a 30-year loan this time, making monthly payments for 30 years will give us a total of 360 payments over the life of the loan. Just so you know, you can't type 12 times 30 into your calculator in this row if you didn't know it off the top of your head. The I% is given in the problem as 4.407, and the PV, the amount of the loan, or the amount of mortgage, the amount of money that Deb and Larry have to borrow from the bank, is still $190,000. And because our calculator is showing us this, which actually I didn't address the negative sign in there yet. The negative sign represents a debit to the account that it's being taken out of. You should never copy that down as part of your answer. You should replace it with a dollar sign and make sure you round to the nearest cent appropriately. Okay, so because this answer is still in my TVM solver here, I'm going to reset that to 0, just so I don't accidentally copy it. And FV is 0 as well, and the PY and CY are 12. So when you type all of this stuff into your TVM solver, what do you get for payment? When you press F4 on the Casio or on the TI, you would put your cursor next to this payment and press the green alpha button and then enter.
$952. and 23 cents.
$952.23, wow. That looks cheaper than the 15-year. So perhaps that might be more appealing to somebody than a $1,400 mortgage. But let's continue on with this, and then we'll find the differences in each. So to find our total amount paid on the 30-year loan, we're going to use the same formula that we did before, payment times N plus down payment. We're here, the payment is $952.23 and is made 360 times, and the down payment is $50,000. So when you multiply payment times N plus down payment, and feel free to pause this video at any time, what do you get for the total amount paid?
$392,802.80.
Did I hear that right? $392,802.80? That's like 80 grand more than the 15-year, just by initial inspection. I haven't figured that out yet. And then the total interest paid, again, payment times N minus PV. So we're taking the $952.23 times the 360 payments and subtracting from that the amount of the loan, the amount that was borrowed from the bank, which is $190,000.
That equals $152,802.80.
Wow. So if Deb and Larry borrow $190,000 to buy this house that they put 50 grand on, they're going to end up paying almost $153,000 in interest alone. That's like a whole other house worth. So you can see there's some differences, right? If we look at the payments, difference in payment, if we take the 15-year payment of $1,458.83 and subtract from that the 15-year payment of $952.23, we find that the 30-year payment is $506.60 less than the 15-year payment. Well, geez, if I had to choose, I might go with the smaller of the two payments. I mean, $506 a month, I could do a lot with that. But the thing that you have to recognize is that in the long run, in 30 years, you're going to pay a lot more in interest. Let's do the difference in total amount paid. So here I have $392,802.80 minus $312,589.40. So, $80,000. And so which one of these is higher? The 15-year total amount paid or the 30-year total amount paid?
I forget what it was, how I got in there.
So the 30-year total amount paid is $80,213.40 higher than the 15-year total amount paid. Did I do my math right?
How did you get the APR for like the 15-year and the 30-year? Like
It was given in the problem.
Okay, because basically like for the project, like
Hang on just a second. If you're going over this with your notes, every time I do this in class, I pull up bank rate and I find the lowest currently offered 15 and 30-year APR that I can. I currently didn't do that this time. I just took what a student gave me as the couple of APRs that she had found. But how do I do what?
like how do you find like do you have to go to a certain website to find a house, or do you just come up with a number and be like I want to pay this
For your mortgage project?
Yeah.
Yes, you find a house to buy and you find two currently offered APRs, one for a 15-year loan and one for a 30-year loan? That's a really good question. And there's a million websites that you can find a house for sale on to find documentation of that. And for the APRs, I suggest bank rate because it gives you so many that you can choose from. But I'm making a video right now, so if you have an individual question, I will address that at the end. Just let me finish up here, okay? So I got this difference in total amount paid, and I also, for my mortgage project, need to calculate the difference in total interest paid. Which one's higher? Total interest paid on the 30-year or on the 15-year?
Total interest paid on a 30-year.
Is higher, right? So we're gonna get that the 30-year total interest paid is some amount higher than the 15-year, 72, 580, 940. And if I did this right, I should get the same answer of $80,213.40. So the 30-year total interest paid is about $80,000 more than the 15-year total interest paid. So even though we see a lower monthly mortgage payment on a 30-year loan, when you look at the long run, saving $80,000 in interest, I think might be worth making a little bit higher payment and getting that house paid off in 15 years instead of 30. Thanks for watching, tune in, and I'll do the amount of the first month's payment applied to principal.